Welcome everyone. Today we are going to explore one of the most widely used technologies in additive manufacturing, the fused deposition modeling, or called as the FDM. What you are seeing now is a live demonstration of an FDF printer in action, layer by layer. The printer builds a 3D object from the ground up using the thermoplastic material. This technology has revolutionized prototyping and small batch manufacturing by offering an affordable and versatile method of creating the function parts. To understand the FDM better, we must first differentiate the additive from subtractive manufacturing. The additive manufacturing creates the object by adding the material layer by layer, while subtractive methods to involve to remove the material through process like milling or cutting machines. The additive process reduces the waste and allow for the complex geometries that are difficult or impossible to produce using the traditional subtractive techniques. Let us now look at the workflow of the FDM. It starts with a 3D CAD model. The design is then processed through slicing software, which converts the model into layer and generates the tooth path. The G code is sent through the printer, where the material is heated and extruded and deposited layer by layer. After the printing, the part is allowed to be cool and undergo some post-processing steps like support removal or surface finishing. An FDM printer is composed of several essential components. The frame, which provides for the structural support. Next, the stepper motor to control the movement along the x-axis, y-axis and z-axis. Next, the extruder assembly, which include the hot zone of the nozzle. Next, the heat build platform for the better adjacent zones. Next, the filament spool, which supplies the printing material. Each of these parts to play a critical role in ensuring the print quality of the machine reliability. Create the 3D model using CAD. To export it is an to STL file. Next, to slice the method using to appropriate slicing software. Upload the G code to the printer, starting the printing process to remove the support and finish the printed part. Each of these steps are essential to ensure the accurate and efficient manufacturing. The extrusion mechanism is a heart of FDM process. The filament is pulled from the spool by feeder gears and pushed into the hot end, where it is to melt at the temperature ranging from 180 degrees Celsius to 250 degrees Celsius depending on the material. The molten plastic is extruded through the nozzle and deposited to build the platform. The platform of the nozzle sits per the tooth path and build the object layer by the layer. There are different types of filaments available in FDM, like PLA, polylactic acid is biodegradable and user-friendly, and next is the ABS, acrylonitrile butadiene styrene, is a stronger and heat-resistant. Next, PET is a very balanced and strength of flexibilities. Each filament has most of unique properties is selected based on the requirements of the applications. Slicing software converts the 3D models into layers and generates the tool paths. The popular slicing like include for Cura softwares and slicer softwares are simplified to 3D. These programs are to customization of the printer parameters like the layer heights or infill density and speed and temperatures, and good slices is not only for ensure the dimensional accuracy, it is also to reduce the material usage of the printing time. The many FDM printers require for the support structure. This is the main role of the machines and to build the parts, especially for overhangs and bridges. These supports are prevent to shagging to ensure the dimensional accuracy after the printing to remove for manually using the tools, and some printers are dual extrusion to print the soluble support which dissolve into the water and other solvents to making the post processing easier. There are several benefits in FDM like cost effectiveness, prototyping for the small batch production and also to wide range materials, easy to use, minimum wastage of material and also to create the complex geometric models. These are advantages. FDM is ideal choice of academic and industries and personal uses. The print imperfections, these are for like the FDM is not without limitation like wrapping, straining, layer shifting, under extrusion or over extrusion. Like wrapping is due to uneven cooling, straining is caused by the filament process, the layer shifting is mechanical issues. The under extrusions are improve the settings, like understanding and troubleshooting is the issues key of to achieving the constant results. The dual extruded FDM printer is offer enhanced functionally. the printing with the multiple materials, to creating the parts with the support structure from the different material, and also to combining the color and the texture in single print. This technology is open to new possibilities in both design and manufacturing. The FDM is widely used for across the industries in various application. In engineering for the rapid prototyping, the medical fields for the prototyping or surgical models and different prototypes, in automobile and aerospace for testing and tooling purpose, and education for teaching and design and manufacturing principle. It is a versatility and affordability make it for the modern digital manufacturing. Thank you all of your attention. I hope this lecture has helped you again for comprehensive understanding of FDM in additive manufacturing.